So good morning dear students, welcome to the next session of engineering drawing, design and safety. So yesterday, we have discussed about this engineering curves. So in the engineering curves, we have made a small classification. So in the small classification, the first thing we will study about the cycloidal curve. In the cycloidal curve, we will discuss about the cycloid, epicycloid, hypercycloid and so on. Then we will go for involute and finally we will go for the spirals, correct. So the first one we are going to start is your cycloidal curve, right. In the cycloidal curve, the first thing we are going to discuss is called as cycloid and trochoid, correct. Cycloid and trochoid. Right. So what is cycloid and trochoid? When it is formed? So generating circle rolls on a directing line. Correct. Cycloidal curve, cycloid and trochoid. Cycloid and trochoid means generating circle rolls on a direct line. For example, this radius is r, suppose this is center O dash, it is rolling on a directing line. This is called as generating circle because this is the circle which is going to generate the curve, and this is called as directing line. Correct. So for the cycloid and trochoid, generating circle rolls on a directing line, right. Now see, there can be three possibilities. What are those possibilities? Suppose let us consider 3 points. One point which is lying on the circumference of the generating circle, one point which is lying outside, and one point which is lying inside, correct. So you can see that for a circle or for us, you can think of like this, that a cycle or a vehicle, a wheel is moving on a road. So this is your cycloid and trochoid, fine. So suppose a motorcycle or a car is wheel is rolling on the road, right. So this is any wheel and it is the road, correct. Okay, so this is the generating circle and this is called as directing line. Now there can be three possibilities. The first possibility is that the point you are going to consider on the circumference of the wheel. For example, suppose a chewing gum is stuck to the tire. A chewing gum is stuck to the tire. So when the tire will rotate, the chewing gum will also rotate, and simultaneously this will also move forward, right. So because a vehicle whose tire is rolling or whose wheel is rolling, it will roll as well as that means there is a rotary motion and there is a translatory motion also, right. So when the wheel rotates, then there will be rotation as well as forward translation. So similarly, if a chewing gum is stuck to the tire, so when this tire is rolling, So this chewing gum will also rotate. Simultaneously, this chewing gum will also move in the forward direction. So a curve will be traced. Those curves are basically called as cycloids. Correct? We will discuss all the curves one by one. You can see that within the wheel there are nut bolts which tighten the wheel, right. So if this circle is rolling, or if this wheel is rolling, this nut bolt will also rotate and it will also move in the forward direction. So you are going to get a curve, isn't it? So you are going to get a curve. Similarly, suppose a pin is there or some nail that has stuck to the tire. When it is rotating, this nail will also rotate, a curve will be traced, right. So therefore we have three region in which, or three curves that we are going to generate. So let D is distance of point, D is distance of point from the center of generating circle. Fine. If I consider D is the distance of the point from the generating circle, then if D is equal to R, so where is D is equal to R? So this is your D is equal to R, isn't it? This will be D equal to R. If D is equal to R, then the curve that is traced, it is called as cycloid. If D is greater than R, so in this curve, where is D greater than R? So D is greater than R, that means the distance of the point is the distance of the point from the center of the generating circle is greater than its own radius. So then the curve, always remember, when the point is lying outside, that D greater than R, that means the point is lying outside, right. So because we always consider the reference to be the point of contact. So if D is greater than R, the curve, that is a word will be used called as superior. So when there is a word superior, means the point is lying outside, and this curve is called as superior trochoid. It is called as superior trochoid. Similarly, if D is less than R, in that case the curve is called as inferior trochoid. That is called as inferior trochoid. Correct. So that is called as inferior trochoid. So here one by one we will discuss everything. Clear? So when the point is lying inside, a word is used called as inferior. Correct. So one by one we will discuss. The first one is your cycloid. Now in detail we will discuss everything. Cycloid. Cycloid means point lying on generating circle. That is D is equal to R. Yes, good morning everyone. Bipojit, Paul, you don't have to carry anything, just carry your notebook and just attend these online lectures. Okay. So let us see about this. So point lying on generating circle. Clear? Okay. So here we are going to draw a curve. Let us see. Let us say these are the centers of this circle. The circle is rolling in the forward direction, correct? So what is the name of this circle? This is a generating circle, this is a directing line. This is your generating circle and this is your directing line, correct, isn't it? Okay. This is your D, it is equal to 2R, isn't it? Fine. So we have D equal to R. Now see, fine. See, now let us say this is the curve, right, or this is the circle, generating circle. Now when it will rotate, you can see that there is a mark here, right. So if you see that there is a mark here, see there is a mark here. So if it rotates, what will happen? Now if it is like this, if it rotates, if the generating circle rotates, this point will move like this, correct. So after some time the point will move upward, correct, upward. After that, when it is going to rotate further, so there will be translation motion also, it will move forward also, the point will come here, right. So first the point will be here when it is moving, right. So that means the point is initially here, so when it is rotating it will move upward, and further when it is rotating it will move downward, right. So I have used some discrete time. So discrete time is what? So I have shown you at discrete time means what I am assuming is, in this particular case, say let us say initially the point was here, isn't it? Initially the point was here. This is the, sorry, one second, let me copy this first because I will require it. Fine. Now see. So let us say the point is here, right. This is O dash. So if I ask you what is this distance, you will say that this distance is D is equal to R, correct. So cycloid means point lying on generating circle. So point is lying on the generating circle. After some time, this circle will rotate. As the circle rotates, the point will move, and let us say when the circle is over here, let us consider when the circle is over here, the point is exactly over here. You can take, see I have taken 3 circle, you can take more than that. That means intermediate position also you can draw, but you know we have to draw only the curve, सिर्फ curve बनाना है. This is the point. So after some time this point will go up, after some time this point will come down, isn't it? So these are the discrete time. Discrete time means at instant of time. Maybe it is 1 second, 3 second, 5 second, like this. Now there is a possibility that the this point will lie here also, like this, right. So just now I showed you that initially let us say the point is here, after rotation the point will move upward, after rotation the point will come down, right. So what you can observe here, from here to here, so I have taken one complete round, right. So I have taken one complete round, isn't it? So this is your how much? It is 2 pi r, which is same as pi into d, correct. So this is a pi d diameter, correct. Now so I have to draw the cycloid. So what I have to do is, now what I will do is I will just join all the points, right. So let me join these points, isn't it? So if I join the points, I will get a curve like this, isn't it? So you can see that at various instant of time also you will get this. So if I join all these 3 points, so I am going to get a curve. So this curve, now similarly if it rotates from here, or if it rotates forward direction furthermore, correct. So right, fine. So that means if it is coming from back, it will come here, again it will make a curve and then it will go. So this curve is basically called as cycloid, right. So this curve is basically called as cycloid, correct. This curve is called as cycloid, understood? So this curve is called as cycloid, right. So those who missed the class, please take the screenshot, or you can take this photo, right. In the last class we have studied till here, right. So just take the photo and move forward, because right. So where we find the application of this, where we use this kind of curves, application, right. So it is used in mechanical clocks. What are mechanical clocks? Mechanical clocks are those clocks in which there used to be pendulum, right. So at 12 o'clock it stuck 12 times, at 1 o'clock it stuck 1 time, at 2 o'clock it will stuck 2 times. So those are basically called as mechanical clocks, with that is clock with the pendulum. Now we have digital and without pendulum also, but in the olden days there used to be a clock which were having a big pendulum and it used to oscillate. Second is your, it is a curve of fastest descent under gravity. Now what is the meaning of this, correct? So let me you first draw it. I will tell you what is this meaning of this. It is the curve of fastest descent under gravity. Fine. Now, see very carefully. What is the meaning of this? So, let me show you one slide. See this one. You can see that there is a curve, right? So, this is your called a cycloid. So, you can see that in this particular figure or the animation what you can see over here, a circle is rolling on a directing line, that is the generating circle is rolling on a directing line. So, when I am saying rolling, that means it is pure rolling. Pure rolling means what? There is no slipping, no sliding. So, when I am saying pure rolling means there is no slipping, there is no sliding, it is rolling perfectly, right. So, it is taking a complete one round, isn't it? So, you can see that the circle is rotating a complete round and you are going to get a curve, the red line is showing the curve. So, this is called as cycloid, right. I hope now it is clear. So, what is your cycloid? Isn't it? Okay. Next, I am saying that now you can see that there are three curves. This is the curve number 1, this is the curve number 2, and let us say, or curve number 2, and let us say this is curve number 3. So, there you can see that there are three curves. Now, this yellow one, what you can see, it is the cycloid, correct, it is your cycloid. So, you can see that there are three balls which are basically simultaneously released, right. So, we have three balls which is simultaneously released. So, when these three balls are simultaneously released, you can see that the ball which is going on the yellow line, this yellow is nothing but your, this yellow is nothing but your cycloid curve, right. So, this is the cycloid. You can see that the ball, which ball is reaching the which ball is reaching first, you will say that that ball is reaching first which is following the curve yellow line, right. So, that means this is called as the curve of the fastest descent under gravity. So, when three balls are simultaneously released, the ball which reaches first is the one which follows the cycloidal curve. I hope it is clear, isn't it? Yeah. So, that is the basically meaning of this. So, it is a curve of fastest descent under gravity, right. Next, fine. So, it is a, so that is if you want to see here. So, as an example you can write for your reference, suppose we have three curves, right. So, if three balls are simultaneously released, right. So, one ball will be here, another ball will be somewhere here. So, the one which will reach first, right, is the one which is following the cycloidal path, isn't it. So, this ball is the one which will reach first, right. So, that is called as curve of fastest descent, right. I hope things are clear. Next, understood till here? So, that is called as cycloid curve. Now, second one, okay, so I have written A. B. it is your superior and inferior trochoid. Superior and inferior trochoid. What is that? So in this, point lying outside instead of and, let me put or. Point lying outside or inside generating circle. Right, that is D greater than R or D less than R. Fine. So for me it's easy now because I need to do copy and paste. आपको बनाना पड़ेगा, so you please draw it till here. Right, so if you have any doubt you can ask. Right, so point this is your O dash, O dash, O dash. This is also center O dash, center is O dash, correct. So center is your O dash. Now see, there are two possibilities of the point. What are the possibilities? The point may lie inside or the point may lie outside. So superior if the point is lying outside, inferior if the point is lying inside. Now when it will rotate, the point will be inside here, the point will be outside here, isn't it? Similarly, the point will be outside here, the point will be inside here. So these are the relative position of the points, isn't it? Okay. So what you can make it out from here is this is one distance, right? So from here this is one distance, you can check it out, and this is another distance that you can check it out, right? So this is one distance and this is your another distance. Right. So, what you can make it out here, this is your d less than r, right. So, this is your d less than r and this is your d greater than r, isn't it. So, these are the two position, relative position, right. So, in the same, in this one figure I am showing all the two graphs, right. So, this distance is d less than r and this distance is d greater than r, correct. Okay. So, if I join these points, I will get one curve, isn't it. So, if I join this point, I will get one curve, and if I join the bigger one, so that means this one, if I join a bigger one, so I am going to get a curve like this, isn't it. So, there are two curves that are basically formed, isn't it. So, two curves are formed, this is one curve, so this is one curve and this is another curve, isn't it. So, two curves are formed, one is this one, another is your this one, correct. So, what is the name of these curves? So, this curve, the first one which is lying outside, so the word superior will be used. So, this is your superior trochoid, correct. This is called as superior trochoid, and if for this curve you can see that the point is lying inside. So, a term inferior will be used. So, it is called as inferior trochoid, correct. So, in a single figure you can see that I have drawn superior as well as inferior, correct. Now, where these curves are used? So, in engineering drawing these curves are not used for our BTech level, means in our BTech study. This is used for the naval architecture, because the wave profile in the ocean or the sea, it approximate these kind of curves, right. So, the wave in the ocean or in the sea, so these are basically approximate the trochoidal curve. So, that is why these kind of curves are basically used in the naval architecture, right. So, it approximates the wave profile, hence used in naval architecture. ठीक है. फाइन, डन. नाउ सी, देखो ये हमने आपको दिखाया था साइक्लॉइड. दिस वाज बेसिकली योर application of cycloidal curve. Now just look at this figure or the animation. Now you can see that a wheel is rolling, pure rolling is there, and there are 3 points. One point which is lying on the circumference, which is shown by the green color. One which is lying on inside the circle, which is shown by blue color, and one lying outside, which is shown by red color. Right, when the circle rolls a complete cycle, one complete cycle, you can see that the green one, it just touches the surface and it comes back, right. So you can see that it just touches the road or the line, correct. But the superior one, the red one, it is making a node. You can see that a notch is formed. So it is coming, it is going beyond the line, and it is again making a small node and it is coming outside, right. You can see that. So that is why I have drawn the curve like this. Now if I draw complete, so there is a node formation that you can observe. And when the blue line, if you see that the blue one, which is your inferior, it neither touches, right, and neither making any nodes. So it is just above the directing line. So this is the directing line. You can see that the blue one, see the blue one, it is neither touching, it is not neither making a node. So it is just a smooth curve that is formed. So this is the 3 curve that we have just seen, cycloidal curves. So superior, inferior, as well as cycloid. I hope things are clear. Okay. So next, Amit Yadav, it is not allowable architecture, it is naval. Arey bhaiya, it is N. Correct? Okay. Now, so this was how I have written AB, and this is your cycloid. Okay. Next, coming to the next one, B. B is your epicycloid and epitrochoid. So what is your epicycloid and epitrochoid? See, generating circle rolls outside direct, generating circle rolls outside directing circle. Correct? That is called as epicycloid. So epicycloid and epitrochoid means generating circle rolls outside directing circle. So let me show with an example. Suppose this is the smaller circle, and let us consider we have a bigger circle as well. Fine. So here let us consider this has some radius capital R, and let us say this has small radius small r. This is center capital R, this is your say O dash, and this is your small r, right. Now again we have 3 points, the same situation will be here. This is, it has certain name, it is the first, the top one, right? So this is called as generating circle. Why it is called as generating circle? Because this is the circle which is going to roll and which is going to produce the curve, right? This is the generating circle, and this is called as directing circle. Now since it is not a line, so that is why in short I am writing. So this is your directing circle, correct? So we have generating circle and we have directing circle. Clear? Okay. So generating circle, it is rolling outside the directing circle, right? So here we can see that we have 3 points. One point is here, so this is your P outside. This is the point of contact, so this is your P on the circumference, and here one more point is there, this is P inside. By default we will always consider P on as the reference, right? So with respect to this point, this will be outside and this will be inside, isn't it? So the same situation, let D is equal to distance of point from the center of generating circle, right? So let D is the distance of the point from the center of generating circle. Then if D is equal to R, the curve that is traced, it is called as epicycloid, right? If D is greater than R, then the curve that is traced, now D greater than R, okay. So in this diagram, where is D equal to R? So you will say that this one, this is D is equal to R, isn't it? Here this will be D greater than R, and the above point is D less than R. So I hope it requires no explanation. This point is D equal to R, D greater than R and D less than R, right? So the curve, now the point is lying outside, a word will be used called as superior, correct? And AP will remain as it is, cycloid will convert into trochoid. So AP superior, AP trochoid. If D is less than R, in that case the curve that will be traced, since the point is inside, so the word will be used as inferior, right? Inferior means the point is lying inside, and the word AP will retain, cycloid will convert into trochoid. I hope things are clear. So this is the basically, now individually we will draw the curve and we will see the application as well, right? येशु यादव सर, यहाँ से कैसे क्वेश्चन पूछा जा सकता है? बहुत ही अच्छे क्वेश्चंस इसमें बन सकते हैं. फॉर एग्जांपल, सो इफ यू डू योर वर्क बुक यू विल कम टू नो, क्योंकि इस पे भी वर्क बेस्ड क्वेश्चंस है. बहुत सिंपल सा क्वेश्चन इस तरीके से पूछा जाएगा, इफ अ जनरेटिंग सर्कल इज रोलिंग ऑन अ डायरेक्टिंग लाइन, द कर्व ट्रेस्ड इज कॉल्ड एज, और इफ द पॉइंट इज लाइंग आउटसाइड द जनरेटिंग सर्कल एंड इफ द सर्कल इज रोलिंग ऑन अ डायरेक्टिंग लाइन, व्हाट इज द नेम ऑफ द कर्व? नेम के हिसाब से पूछा जा सकता है. जैसे इसके अंदर ये पूछा जा सकता है, इफ द सर्कल इज रोलिंग आउटसाइड अनदर बिगर सर्कल, रोलिंग आउटसाइड and the point is lying on the circumference, what is the name of the curve? Or point is lying inside and then it is rolling, what is the name of the curve? एक तो नाम से पूछा जाता है ना, तो आपको पता होना चाहिए कि कब सुपीरियर वर्ड यूज करना है और कब इंफीरियर वर्ड यूज करना है. और जब आप वर्कबुक के क्वेश्चंस करोगे, वर्कबुक के क्वेश्चन बहुत आसानी से लग जाएंगे, आपको 2-5 मिनट भी नहीं लगेगा पूरे क्वेश्चंस करने में. मैंने जो आपको पढ़ा दिया, वॉट एवर आई टॉट यू, एंड इफ यू सॉल्व योर वर्कबुक, इट विल नॉट इवन टेक 5 मिनट्स टू कवर इट, राइट? फटाफट देखोगे क्वेश्चन एंड यू विल डायरेक्टली टिक इट, राइट? एंड आई डोंट थिंक सो कि इतना कोई स्ट्रेनियस चीज हम पढ़ा रहे हैं कि आपको याद. हाँ, दिस नेम्स आर बेसिकली यू हैव टू रिमेंबर. एपिसाइक्लॉइड क्या होता है, सुपीरियर का मतलब आउटसाइड, inferior means inside and so on, right? Okay, so until and unless you solve the question you will not able to understand. Fine, okay, whatever. Now the situation is such that you have to, है ना, कि याद रहे और एग्जाम में आ जाए तो आप कर लो, है ना. अभी इतना इसके ऊपर रिसर्च करने का भी समय नहीं है, बिकॉज इट इज़ वेरी हाईएस्ट टाइम, इजंट इट? ओके, चलो यहाँ तक लिख लो, कहानी होगी. नाउ द फर्स्ट वन आई विल डिस्कस, इट इज योर एपिसाइक्लॉइड. So the first one I will discuss, it is called as epicycloid. Epicycloid means point lying on generating circle. that is D is equal to R, isn't it? So I hope everybody has written this one. So the first curve I am going to discuss, it is called as epicycloid. So point lying on generating circle, that is D is equal to R. Correct. Now see. So these are the centers, isn't it? So let me center O, O dash, O dash, O dash. The circle is rolling in the forward direction, isn't it? Okay. So this is your generating circle and this is your directing line circle. d equal to 2r, isn't it? Fine. So now I can make a copy of it. So where is the point lying? So point lying on the generating circle. So where will be the point? Point lying on the generating circle. So after rotation, where the point will move? It will move upward, and after some time, where the point will move? It will move here, isn't it? So this is the position of the point. So as the circle rotates, the point will move upward, and after some time the point will move downward, isn't it? So you can see that this distance is your d equal to r, isn't it? Clear, everyone? So note it down. Here directing circle is stationary. करेक्ट. ये डायग्राम रह गया था, जल्दी बनाओ फटाफट. ट्राई. फाइन. सो इन द नॉर्थ इंडिया बहुत ज़्यादा कोहरा और बहुत ज़्यादा फॉग. द विंटर इज शोइंग इट्स ट्रू कलर. सो बी केयरफुल, है ना. एग्ज़ाम भी है आपके नेक्स्ट मंथ. सो टेक प्रिकॉशन मेजर्स, है ना. बाहर काफ़ी ठंड है, हमारी गले की वाट लग गई है. सो डोंट मूव अननेसेसरी आउटसाइड. ट्राई टू कवर योर सेल्फ. कवर करने के बाद भी क्या है, बहुत मुश्किल है. खैर चलो. दिस इज व्हाट नाउ. व्हाट यू हैव टू डू इज यू हैव टू जस्ट मेक द कर्व. इसंट आपको क्या करना है. सो यू हैव टू ज्वाइन द पॉइंट्स. Right. So this curve is called as epicycloid. This curve is called as epicycloid. Now where we use this kind of curves? Application. Designing rotary pumps, blowers, etc. So these rotary pumps and blowers, these are used in industries. घर वाला नहीं है, घर में blowers जो लगाते हो ठंड में वो नहीं. Right. So it is a rotary pumps. Fine. तो इस बार का ठंडा जो है बहुत ही खतरनाक है. सो यू हैव टू बी वेरी मच केयरफुल, है ना. बहुत ही केयरफुली, सतर्कता के साथ आपको रहना पड़ेगा. राइट. सो यू हैव टू बी वेरी मच केयरफुल बिकॉज दिस ईयर विंटर इज क्रिएटिंग हैवॉक. राइट. ओके. सो दिस इज कॉल्ड एज डिजाइनिंग रोटरी पंप्स, ब्लोअर्स एटसेट्रा. तो इसको हम लोग बोलते हैं ठीक है. ओके. बी सुपीरियर और inferior epitrochoid. Correct. So in this point lying outside or inside generating circle, that is D greater than R और D less than R, है ना. सो नेक्स्ट वी हैव सुपीरियर एंड इंफीरियर. तो चलो इसको भी देख लेते हैं, है ना. फाइन. नाउ ठीक है, ये बन गया होगा. सुपीरियर एंड इंफीरियर. वेयर इज द कर्व. ये रहा कर्व. बनाया कर्व. So draw it till here, then I will बनाइए उसको, जब तक बनाते रहिए। ओके, this is the position of the point P, 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 isn't it? D less than R, D greater than R, है ना? सो एक ही कर्व के अंदर we have to alert from winter season, sir, this year. कस्तूरीदास सर, इफ़ यू आर फाइन वी आर ऑल्सो फाइन। अच्छा सर, इतनी ठंड तो होनी ही चाहिए, घर बैठे हिल स्टेशन का मज़ा आ रहा। करेक्ट, बात में तो दम है ना। विंटर में ठंडी नहीं आएगी तो कब आएगी, है कि नहीं? सही बात। सी, डन टिल हियर। नाउ व्हाट यू हैव टू डू, यू हैव टू जॉइन दिस पॉइंट्स, करेक्ट, एंड अनदर, fine. So these are the two curves that we have to join, fine. So similar type of curve is there, इसमें कुछ नया नहीं है, so all the things are similar, isn't it? So this is one curve and this is another curve. So we have two curves, this is one, so this is your superior epitrochoid and this one is your inferior epitrochoid, correct. So where these curves are used, again in naval architecture application, it is used in naval, फिर से बोलेंगे अलावल, है ना, naval architecture. Clear? Done? Done? Now see, this is your epicycloid. So you can see that the curve is rolling, sorry, the circle is rolling outside the generating circle. Now one thing you can observe that there is complete 3 rotation, so you are getting 3 epicycloidal curve, right. Now what you can observe over here is, what is the capital R. Now this is the directing circle, right. So this is your directing circle, right. So if I talk about the capital R, how much it is? You will say it is 3, isn't it? Capital R is 3. Now what is the radius of small r? So if you see here, this is the radius, right. So small r is how much? It is 1, isn't it? So how many curves are there? So how many epicycloid is formed? You will say that here number of epicycloid, how much it is forming? Number of epicycloid, how much it is forming? It is 3, isn't it? You can see that. So how you will get 3? Here you can see that r is equal to 3, small r is equal to 1. So if I say k, which is the radius ratio r upon r, so this is how much it is, 3 upon 1, how much it is, 3. That means number of epicycloid that is formed, it depends upon radius ratio, isn't it? So if n is the number of epicycloid and if k is the radius ratio, this is k, this is the k is the radius ratio. So here k is your radius ratio. So the number of epicycloid depends upon the radius ratio. As much radius ratio is there, that much of epicycloid you are going to get, isn't it? So I hope it is clear. So you can see that epicycloid and you can appreciate this analysis that we have done, right? So if n is the number of epicycloid and if k is the radius ratio, then number of epicycloid will be always equal to radius ratio. It is quite clear from this particular figure, है ना? देखो आपके सामने ही है ना? So what I can say here as a note, if k is r upon r, which is also known as radius ratio, r upon r, which is called as radius ratio, and n is number of epicycloid formed. Then n is equal to k, provided it belongs to positive integer, correct? So radius ratio should be integer. Now if you say it is a fraction, like suppose 5/2, what will happen, right? So if k is equal to r upon r, suppose 3/2, so 3/2 is not an integer, but 3/1 it is an integer because r will become 3. So if, right, note number 1, n equal to k, right. Note number 2, if radius ratio r upon r is equal to p upon q form, right, that is rational number, find. So if k is equal to radius ratio which is of the form p by q, that is rational number where q is not equal to 0, then number of epicycloid formed, will be p in q revolution. What does that mean? So it means that number of epicycloid that will, suppose for example if k is equal to 3/2, it means that 3 epicycloid will be formed, 3 epicycloid is formed when generating circle rolls 2 times entirely on the directing circle. तो ऐसे चीज पूछेगा नहीं आपसे, लेकिन ये एडिशनल इंफॉर्मेशन है, राइट. इफ k is equal to capital R upon a small r, that is p upon q form, that is rational number, then number of epicycloid formed will be p in q revolution. Means अगर k की वैल्यू 3/2 है तो 3 एपिसाइक्लोइड बनेगा, लेकिन इसके लिए सर्कल को, जेनेटिक सर्कल को 2 कंप्लीट राउंड लगाने पड़ेंगे अराउंड द इंटायरली ऑन द डायरेक्टिंग सर्कल, है ना. 2 बार घूमना पड़ेगा, ठीक. यानी 2 बार घूमना का मतलब है, सपोज यहां से शुरू हुआ, ये एक चक्कर लगा और ये दूसरा चक्कर, है ना. 2 चक्कर में लगाने पड़ेंगे तब जाकर के 3 एपिसाइक्लोइड बनेगा. तो ऐसे क्वेश्चन आपसे पूछेगा नहीं, लेकिन एडिशनल इंफॉर्मेशन हमने आपको दे रखा है, करेक्ट. तो ये चीज आपसे पूछेगा नहीं एग्जाम में, लेकिन फिर भी आपको हम थोड़ा सा एडिशनल इंफॉर्मेशन दे रखे, फाइन. तो अगर रैशनल फॉर्म में है, जैसे 3/2 है, तो 3 एपिसाइक्लॉइड बने, लेकिन 3 को बनाने के लिए 2 बार घूमना पड़ेगा। ठीक है, अब देखो इसके लिए मैं आपको थोड़ा सा और ब्रीफ कर देता हूं। इसको देखो, स्टार्टिंग पॉइंट ये है ना, यहां से स्टार्टिंग पॉइंट ये है, कितने एपिसाइक्लॉइड बने? 3। कितनी बार घुमाइए? कंप्लीट राउंड एक बार ही हुआ ना, यहां से चला और ये सर्कल घूम करके वापस यहां तक आया, तो कितने एपिसाइक्लॉइड बन चुके हैं? 3 बन चुके हैं। लेकिन अगर 3/2 है तो यही 3 एपिसाइक्लॉइड बनाने के लिए इसको एक बार यहां से चल करके दोबारा यहां आना पड़ेगा। ठीक है, यहां पे आने के बाद और एक राउंड लगाएगा, टोटल 2 राउंड लगेगा, तब जाकर के 3 एपिसाइक्लॉइड बनेगा। ठीक है, अगर रैशनल नंबर हुआ तो। करेक्ट, 3/2 मतलब यहां से शुरू करेगा, एक राउंड लगाएगा तो 1.5 ही एपिसाइक्लॉइड बनेगा, दूसरी बार राउंड लगाएगा तब जाकर के 3 एपिसाइक्लॉइड बन जाएगा। ठीक है, पहला बार में 1.5 बनेगा, दूसरे बार में और 1.5 बन जाएगा, टोटल 3। तो 3/2। अगर आपसे पूछा जाए 5/4, इसका मतलब क्या हो गया कि 5 एपिसाइक्लॉइड बनेगा, लेकिन इसके लिए इसको 4 राउंड लगाना पड़ेगा। ठीक है, ये है इसका मतलब। तो ये सारी चीज आपसे एग्जाम में जनरली नहीं पूछे जाएंगे, लेकिन चूंकि यहां पे बात चल रही है, क्योंकि हमने यहां पे एक शब्द यूज किया इंटीजर पॉजिटिव, सो आई हैव यूज्ड इंटीजर, so that is why you might get the question in your mind, what if it is not integer? So if it is not integer, either it will be rational form or it will be irrational form. If it is rational form, then the numerator will give you the number of epicycloid form, and the denominator will give you how many times it has to revolve about the directing circle to get that point. To get that epicycloid. So if I say k is equal to 3/2, that means 3 epicycloid will be found, but for that the generating circle has to go 2 times. So 1 time and again 2 times, 2 complete revolution, then only it will form the epicycloid. Now again, third thing that you might ask, what if it is irrational? See, this is the thing that the student will ask, क्योंकि उनको इतना बोलोगे ना तो सेटिस्फाई नहीं होंगे, वो बोलेंगे सर, because when you teach any student, so if you say that only this will come, okay fine, but in back of mind these things will go कि what if it is not integer, what if it is not rational. इसलिए मैं लिखवा दे रहा हूं ताकि आप unnecessary टाइम इधर उधर वेस्ट नहीं करो। ठीक है, दिस मीन्स बिलोंग्स टू, इसका मतलब क्या होता है? इसका मतलब होता है बिलोंग्स टू, है ना, मैथ्स में पढ़ा होगा आपने 11-12, बिलोंग्स टू। थर्ड, if k is not p upon q form, then infinite number of epicycloid is traced. Infinite number of epicycloid is traced. ठीक, तो हो गया, कहानी खत्म, अब तो कोई डाउट नहीं रहा। Isn't? So I have given you the complete analysis. तो अगर रेडियस रेशियो इंटीजर है तो क्या होगा? अगर इंटीजर नहीं है, इफ इट इज नॉट इंटीजर, सो इट विल बी आइदर रैशनल फॉर्म और इररैशनल फॉर्म, राइट? सो p/q फॉर्म, दैट इज इट इज कॉल्ड एज इररैशनल फॉर्म। करेक्ट। सो इफ इट इज इन द रैशनल फॉर्म, then number of epicycloid, p will give you the number of epicycloid form, and q will give you how many revolution it has to make on entirely on the directing circle. Correct? And similarly, if it is not irrational number, then infinite number of बनता ही जाएगा, बनता ही जाएगा, बनता ही जाएगा, अनंत काल तक ये बनता जाएगा। करेक्ट? बुझ गए? तो चलो, ठीक, now see application. Okay, so a little more about this, right? Now this is basically your epicycloid. See, this is your epicycloid, this loop, it is called as epicycloid. This is also your epicycloid, this is also your epicycloid, this is epicycloid, this is epicycloid, and this is एपिसाइक्लॉइड, राइट? इसको बोलते हैं, ये सारे क्या है? इट इज कॉल्ड एज एपिसाइक्लॉइड। करेक्ट? इसको बोलते हैं एपिसाइक्लॉइड। नाउ ओके, Clear? See here, this is the curve that we have got. So you can see that in this particular example, a circle is rolling outside the generating circle. I प्लस का मतलब होता है पॉजिटिव इंटीजर. सचिन, I प्लस का मतलब होता है पॉजिटिव इंटीजर 1 2 3 4, क्योंकि रेडियस रेशियो कभी नेगेटिव नहीं हो सकता है ना, तो पॉजिटिव. I प्लस का मतलब होता है पॉजिटिव इंटीजर. P बाई क्यू फॉर्म वेयर क्यू इज नॉट इक्वल टू 0 का मतलब होता है रैशनल नंबर, और इट इज नॉट इक्वल टू P बाई क्यू, तो इसको बोलते हैं इरेशनल नंबर. ठीक है. अब इस फिगर में देखिए, जनरेटिंग सर्कल क्या हो रहा है, रोल कर रहा है किसके ऊपर, डायरेक्टिंग सर्कल. इसमें भी वी हैव 3 पॉइंट्स, वन पॉइंट लाइंग ऑन द जनरेटिंग सर्कल, अनदर पॉइंट लाइंग आउटसाइड जनरेटिंग सर्कल, एंड अनदर पॉइंट इज लाइंग इनसाइड जनरेटिंग सर्कल. So if you can see that if the point is lying on the generating circle, so it is just touching and coming. So you can see that how many epicycloid is formed. You will say that 2 epicycloid is formed. So that means in this particular example the radius ratio will be how much? It is 2. That is capital R upon small r is equal to 2, because in 2 complete revolution you are getting 2, right? Now similarly, if radius ratio is greater, if the point is lying outside, you can see that a node formation is there, and when the point is lying inside, it is neither forming node, neither it is touching the directing circle. So this is basically your superior, inferior and epicycloid, isn't it? Clear? दिख गया कर्व कैसा बन रहा है? तो इसमें रेडियस रेशियो कितना है? इट इज 2. ओके, नाउ यहां पे एक चीज देखिए, you can see that this radius, so here how many epicycloid is formed? 1. So what will be its radius ratio? It will be 1. इस कर्व को बोलते हैं कार्डोइड. क्या बोलते हैं? कार्डोइड, राइट? सो हियर देखो एक कंप्लीट रेवोल्यूशन है, सो इन ए कंप्लीट वन रेवोल्यूशन 1 एपिसाइक्लॉइड इज फॉर्म, इसको बोलते हैं कार्डोइड. यहां पे देखो कितने कर्व बन रहे हैं? 2. इसमें रेडियस रेशियो क्या होगा? इट इज 2. सो है ना, इसको बोलते हैं नेफ्रॉइड. नेफ्रॉइड मतलब होता है किडनी जैसा, किडनी, लाइक किडनी, राइट? तो हो गया 2. इसमें देखो कितने बन रहे हैं? 3 बन रहे हैं. तो इसमें अगर आपसे पूछा जाए रेडियस रेशियो कितना होगा, आप बोलोगे 3. इसका कोई नाम नहीं है, ये नाम है. इसमें रेडियस रेशियो कितना है? 4. इसका मतलब ये हो गया कि इफ यू चेंज द रेडियस रेशियो, राइट, प्रोवाइडेड रेडियस रेशियो इज ऑलवेज एन इंटीजर. ये देखो हमेशा इंटीजर है, और एग्जाम में आपको इंटीजर ही पूछा जाएगा, नॉन इंटीजर या फिर रैशनल इरैशनल नहीं पूछा जाएगा, लेकिन फिर भी एडिशनल इंफॉर्मेशन आई हैव गिवन यू, right? So if it is a integer, so number of epicycloid is equal to number of radius, is equal to the radius ratio, right? तो आप ये देखो कि आपके पास टोटल कितने आ गए? चारों ग्राफ हमने बना दिया है कि नहीं? बताओ, यहाँ तक क्लियर है? समझ में आ रहा है कि नहीं? तो इसी चीज को हम क्या करेंगे, यहाँ पे बना देते हैं. सो राइट, सो हम एक टेबल बनाते हैं यहाँ पे, उसको आप बना लीजिए. Radius ratio, okay. So this is your epicycloid. Epicycloid means D is equal to R. This is your superior epitrochoid, D greater than R, and this is your inferior epitrochoid, D less than R. So here k is equal to 1. That means capital R is equal to small r. Here k is equal to 2. That means capital R is equal to 2r. Correct. तो चलो ज़्यादा तो नहीं बना रहे, बस आपको एक आइडिया के लिए हम बना दे रहे हैं. राइट. सो फॉर एपीसाइक्लॉइड कर्व कैसा बन रहा था? एपीसाइक्लॉइड, एपीसाइक्लॉइड के लिए कर्व कैसा बनेगा? ऐसा. इजंट इट? फॉर सुपीरियर, सुपीरियर के लिए कैसा बनेगा? एक इस तरीके से. देयर विल बी नोड फॉर्मेशन, है ना, जलेबी जैसा. करेक्ट. इंफीरियर, इंफीरियर में क्या होगा? इट विल नॉट टच. सो यानी कि इट इज लाइक अ सनफ्लावर. k इक्वल टू 1 मतलब क्या होगा? एक ही कर्व बनेगा. इसको क्या बोलते हैं? कार्डोइड. यहां पे अगर बनाओगे तो कैसा बनेगा? एक नोड फॉर्मेशन होगा ऐसा, और यहां पे कैसा बनेगा? ठीक है. k इक्वल टू 2. ठीक. इसको क्या बोलते हैं बच्चों? इसको बोलेंगे नेफ्रॉइड. है ना. तो किसी भी रेडियस रेशियो के लिए आप इसको निकाल सकते हो. राइट. ठीक है. इसको ड्रॉ इट. डन एवरीवन? समझ में आ गया ना कैसे कर्व बना रहे? राइट. सो दिस इज हाउ द कर्व. तो आपको कोई भी अगर आप दे दिए कर्व, ठीक. करेक्ट, ये समझ में आ गया। चलिए इसको क्या दिए थे हम, ए बी, ठीक। नाउ कमिंग टू द लास्ट वन, C1। it is your hypocyclide and hypotrochoid। इसका मतलब क्या है? इसका मतलब ये है generating circle rolls inside directing circle। जैसे कि एग्जाम्पल के तौर पे ठीक है। नाउ सी द सर्कल, सपोज इट रोल्स इन दिस डायरेक्शन, राइट। Again we are taking the same situation. This is point P out, this is P on, and this is P in. So this is always considered to be the reference, correct? Now can you tell me, if I rotate circle in anti-clockwise direction, where it will go, isn't it? देखो, this is one circle, this is another circle, correct? ध्यान से देखना, ये सर्कल, you can see that there is a crack over here, आपको एक क्रैक दिख रहा होगा, क्रैक को ध्यान देना, ये ऐसे है, ठीक है? ये कैसे है? ऐसे। When I rotate in anti-clockwise direction, है ना, anti-clockwise, ये सर्कल किधर जा रहा है? It is moving in the forward direction, isn't it? ये किधर जा रहा है देखो, so it is rotating, if I rotate it in the anti-clockwise, ये आगे बढ़ रहा है। अगर इसी को clockwise rotate करेंगे तो किधर जाएगा? It is going backward. So that means if I rotate it in the anti-clockwise direction, it is going in the forward direction. So if I rotate it in anti-clockwise, that means this circle will move here in the forward, ऐसे जाएगा, ये इधर से मूव करना शुरू करेगा, मतलब ये ऐसे रोटेट करके आएगा। If it is in the clockwise direction, it will come back and then it will rotate like this. I hope it is clear, है ना? So let D is distance of point from generating circle. Then if D is equal to R, in that case what is the curve that will be traced? Now see, D equal to R, where will be the point? So here D equal to R, if I say D equal to R, so this point is your D equal to R. So the curve that is traced, it is called as hypocycloid. जैसे मौत का कुआं होता है ना, so in the mouth, what is मौत का कुआं? There will be a well in which the vehicle will go inside. मोटरसाइकिल जो होता है वो चलाते हैं अंदर, तो ये इसमें क्या बनता है? That is your inferior, isn't it? Fine, इस तरीके से। तो ये मशीन्स के अंदर भी होता है, एक बड़ा व्हील होता है, एक छोटा व्हील होता है, छोटा व्हील जो होता है घूमता रहता है, बड़ा व्हील इसको चारों तरफ उसके घूमता रहता है, isn't it? So hypocycloid curve is called as hypocycloid. Similarly, if d is greater than r, उस केस में कर्व क्या बनेगा? So d greater than r. Where is d greater than r? So this is your d greater than r. कर्व जो बन जाएगा, एक शब्द यूज करेंगे सुपीरियर, बिकॉज पॉइंट इज आउटसाइड. सुपीरियर हाइपोट्रोकॉइड. हाइपो विल रिटेन, साइक्लॉइड विल कन्वर्ट इनटू ट्रोकॉइड. हाइपोट्रोकॉइड. Correct? If d is less than r, in that case what is the curve that will be traced? It is your inferior hypotrochoid. Correct? So this is your d less than r. ठीक है. Now we will see one by one. So write it down when you are done. Done everyone? Okay. Now, so first one I will draw for hypocycloid. Hypocycloid, that means point lying on generating circle. Point lying on generating circle. So, circle is rolling in this particular direction, correct? O dash, O dash, O dash. This is your directing circle, or a generating circle. So hypocycloid, that is D is equal to R, isn't it? ठीक है. So first point is lying here. So when it is rotating, ये कहाँ जाएगा? नीचे, है ना? फिर ये ऊपर. So first the point will be here, then the point will come down, and then the point will go up. How? See, देखो ध्यान से, ये point है ना, this is the point you can see here. See, ये point आपको दिख रहा है ना. So when it is rotating in anti-clockwise, anti-clockwise मतलब क्या हो गया? When it is rotating, so it is moving in this direction and the point is coming down. है ना, यही मेन चीज है. Point is here. When you rotate like this, it will come here. If you rotate back clockwise, if you rotate, the point will go like this, and if you rotate anti-clockwise, the point will come down. So that is why after rotation the point has come down, isn't it? So what you have to do is now, अब आपको करना कुछ नहीं है, इसको जोड़ देना है. जोड़ देते हैं इसको. राइट. है ना, इस तरीके से. फाइन. इसको क्या बोलते हैं? सो दिस इज कॉल्ड एज हाइपोसाइक्लॉइड. हाइपोसाइक्लॉइड. ठीक, क्या बोलते हैं इसको, वी कॉल इट एज हाइपोसाइक्लॉइड। ठीक है, it is called as hypocycloid. So where we use the what is the application of hypocycloid? Used in rotary pumps, blowers, etc. ठीक है, यानी कि आप ये देख सकते, आप बोलोगे सर ये तो एपिसाइक्लॉइड में था, हाइपोसाइक्लॉइड का भी, अभी हम दिखाएंगे, सब चीज़ दिखाएंगे, डोंट वरी, ऑल द फिगर, ऑल द फोटोज विल बी सीन, है ना, मैं आपको सारा चीज़ दिखाऊंगा, उसके लिए आप घबराने की ज़रूरत नहीं है। करेक्ट, ओके। हो गया नोट? ठीक है, देखो सी दिस इज हाइपोसाइक्लाइड, अब देखो दिस इज नथिंग बट हाइपोसाइक्लाइड। ना इसमें रोटेशन कैसा हो रहा है, देखो ध्यान से देखो, इट इज रोटेटिंग इन द क्लॉकवाइज डायरेक्शन, सो इफ इट इज रोटेटिंग इन द क्लॉकवाइज डायरेक्शन इट इज गोइंग बैकवर्ड, देखो क्लॉकवाइज करते ही पीछे चला जा रहा है। हमने कैसे लिया था, इफ यू सी हियर व्हाट रोटेशन वी हैव टेकन एंटी क्लॉकवाइज, एंटी क्लॉकवाइज से क्या हो जा रहा है, आगे, ठीक है, एंड ए से एंटी, ए से आगे, सो एंटी क्लॉकवाइज मीन्स आगे जाएगा, कब, हाइपोसाइक्लॉइड केस में। सो इफ द सर्कल रोल, सो एंटी क्लॉकवाइज मीन्स आगे, क्लॉकवाइज मीन्स पीछे, करेक्ट। सो दिस इज हाउ यू कैन सी। सो दिस नाउ इफ आई आस्क यू व्हाट इज द रेडियस रेशियो, कितने हाइपोसाइक्लॉइड बने, सो हाउ मेनी हाइपोसाइक्लॉइड इज फॉर्म्ड, यू विल से दैट 4 हाइपोसाइक्लॉइड इज फॉर्म्ड। सो 4 हाइपोसाइक्लॉइड इज फॉर्म्ड मीन्स it will have the radius ratio r upon r is equal to 4. Same concept, right? Because you can see that epicycloid and hypocycloid, it is nothing but the image, mirror image, right? Epicycloid mein this curve was outside, right? So if I draw like this, it will become epicycloid, isn't it? So epicycloid, and if the same curve is drawn inside, it is your hypocycloid, that's it, right? So here that is why radius ratio is not going to change, first thing. Second thing, you can see that this is called as 3-lobe rotary pump, 3-lobe rotary pump। 3 लोब क्यों बोल रहे हैं, बिकॉज नाउ इफ यू रिमेंबर, थोड़ी देर पहले हमने आपको दिखाया था, ये कहाँ अटक गया, 1 सेकेंड, सी ये था ना 3 लोब, 1 to 3, so it was just a still picture, static picture है। now when it rotates it becomes like this, है ना, so 3 lobe। now in this particular figure if I show you, I have shown you hypocycloid, let me show you, I have shown you epicycloid, where is hypocycloid here, so this curve is your hypocycloid, this curve is your hypocycloid, this curve is your hypocycloid, this curve is hypocycloid, this curve is hypocycloid, This curve is your hypocycloid. So this curve is your hypocycloid, correct, and this red color, it was your epicycloid. So you can see that epicycloid and hypocycloid is the, it will go hand in hand. ये एक सिक्के के दो पहलू है, इसका मतलब in one coin you cannot remove head and tail. Similarly, whenever we have epicycloidal curve, there will be hypocycloidal curve present, right? So this is basically your epicycloid and hypocycloid. Clear? Okay. So this is what it is shown over here. So it is in motion. So you can see that there is a perfect meshing. So the crest part is your epicycloid, and the trough part, it is basically your hypocycloid, right? The crest part is your epicycloid and the trough part is your hypocycloid, isn't it? Okay. Now clear? तो चलो ये आपको हाइपोसाइक्लोइड बता दिया. सो इट इज यूज्ड इन रोटरी पंप्स. अब आप समझ में आ गया कैसे रोटरी पंप्स में यूज कर रहे हैं. नेक्स्ट द बी पार्ट, सुपीरियर एंड इंफीरियर हाइपोसाइक्लोइड. सुपीरियर और इंफीरियर hypotrochoid. So that means point lying outside or inside generating circle. D greater than R or D less than R. आ जाओ. जलीना hypocycloid. So these are the relative position of the points. अच्छा इसमें D equal to R दिखाए थे क्या? Well, this was your D is equal to R. पहला फिगर में D R के बराबर ही हो गया. So in the first figure it was your D equal to R. यहां पे देखते हैं D less than R, D greater than R. अनूप मल्लिक, सर ड्राइंग से इतना परफेक्ट कैसे कटिंग करते हैं यूजिंग कैट टूल्स. कैट टूल्स में हम लोग बनाते हैं सारी चीज एंड द कमांड इज सेंड टू द मशीन एंड इट इज कट थ्रू द मशीन, है ना. मशीन से काटा जाता है, हाथ से नहीं. सारी चीजें कमांड से होती हैं. नोट इट डाउन. correct? डन. ओके, सो चलो इसको हम ड्रॉ कर देते हैं. सो लेट मी ड्रॉ इट. So this is your inferior hypotrochoid. Superior hypotrochoid, where we use it is used in naval architecture. If K is equal to R upon R, called as radius ratio, which belongs to positive integer. ठीक है, यहाँ तक आप पहले बना लो. And N is number of hypocycloid formed. Then N is equal to K. Correct? Same चीज. ठीक है, तो देखते हैं यहाँ जरा. ये देखो, है ना, सुपीरियर, इंफीरियर एंड हाइपो. सुपीरियर, इंफीरियर एंड हाइपोसाइक्लॉइड. तो आपको क्लियरली दिख रहा होगा कि तीन जो है ठीक है, तो इसमें 3 बन रहे हैं, तो यानी कि रेडियस रेशियो इसका क्या हो रहा होगा, R/R, इट इज इक्वल टू 3। करेक्ट, फाइन। अब देखो कहानी में थोड़ा ट्विस्ट आ जाएगा अब इसमें। ये जो इंटीजर होना चाहिए इट शुड बी ग्रेटर इक्वल टू 3। अब आप बोलोगे ये क्या सर, क्या कर दियो ये, ठीक, यानी कि रेडियस रेशियो जो है इट इज एन इंटीजर, दिस इंटीजर शुड बी ग्रेटर और इक्वल टू 3। ठीक, इट शुड बी ग्रेटर इक्वल टू 3। अब बोलोगे ऐसा क्यों सर, अब देखो ध्यान से देखते रहना, ठीक है। सो जस्ट सी इट केयरफुली, राइट। इफ आई से n इज इक्वल टू 1, why it is n equal to greater equal to 3, क्यों, why? So if I say n equal to 1, that means capital R upon small r is equal to 1, that means capital R and small r both will be same, correct. Now why it is greater equal to 3, that we have to understand. देखो ध्यान से, so let us say this is the circle, let us say this is the radius. Now here capital R and small r same, that means O and O dash both are same. That means the generating circle and the directing circle both are of the same size, isn't it? If capital R and small r same, that means both the circle is of the same size, so there cannot be rotation. What is hypercycloid? So hypercycloid is the curve when the circle rolls inside the generating circle, directing circle. So जब तक generating circle directing circle के अंदर नहीं घूमेगा तो curve नहीं बनेगा. So hypercycloid is traced when a generating circle rolls inside the directing circle. If both the circle is of the same size, there will be no rotation. Rotation होगा ही नहीं, isn't it? So you can see that. So R equal to R. So this implies both, that means directing circle and generating circle are of same size. So therefore no hypercycloid will be traced. No hypocycloid will be traced, isn't it? Correct. अब बोलोगे ठीक है सर, मान लिया आप बात सही बोल रहे हो, n इक्वल टू 2 में बताओ क्या होगा फिर, r अपॉन r इज इक्वल टू 2, r इक्वल टू 2r। अब बोलोगे अब क्या दिक्कत है, नाउ देयर विल बी रोटेशन, r इक्वल टू 2r, so there will be rotation, isn't it? One circle is half of that of the bigger circle, so generating circle is half of the directing circle. अब तो रोटेशन होगा, तो फिर क्यों नहीं होगा, तो चलो बताते क्यों नहीं होगा। देखो अंडरस्टूड नो, तो चलो इसके बारे में हम आपको समझाते हैं, है ना। और इस पे क्वेश्चन आया है, सो बेस्ड ऑन दिस इंजीनियरिंग सर्विसेज 2017 में क्वेश्चन आया था, 2017 पे आया था क्वेश्चन। अब समझे क्यों बता रहे हैं, है ना, हम वही बताएंगे जो पूछा जाएगा या पूछा जा चुका है, समझे बाबू। नाउ सी, अब बोलोगे नाउ यू विल से सर देयर इज अ रोटेशन, यस देयर इज अ रोटेशन, यू आर करेक्ट। देन लेट अस सी व्हाट इज अ प्रॉब्लम विद दिस। So let us solve the problem. ये फिट हो जाएगा ना, इसमें थोड़ा सा और बड़ा करना पड़ेगा इसको। परफेक्ट, चलो इसके कॉपी बना लूं मैं, 1 2 3 4 5 6, थोड़ा सा टेढ़ा है ना ये, कोई बात नहीं। Let us assume, suppose initially circle was here, ठीक। So let us assume that initially circle was here. You can take any direction of rotation, any direction. आप बताओ किधर ले, देखो हमने एंटी क्लॉकवाइज लिया था, चलो एंटी क्लॉकवाइज ही लेके चलते हैं। करेक्ट, वी हैव टेकन एंटी क्लॉकवाइज। एंटी क्लॉकवाइज मतलब क्या होता है, आगे जाएगा। एंटी क्लॉकवाइज मतलब आगे। करेक्ट, बताओ। ठीक है, तो अब ध्यान से देखो, दिस इज द सर्कल एंड दिस इज द पॉइंट। नाउ इट इज गोइंग आगे, आगे मतलब किधर जाएगा। सो इफ आई रोटेट इन द एंटी क्लॉकवाइज डायरेक्शन इट विल करेक्ट गो अप, है ना। देखो ये ऐसे है ना, देखो इस तरीके से है, ये पॉइंट यहां है, राइट। तो जब आप इसको रोटेट करोगे तो ये कैसे आ रहा है, ऐसे आ रहा है। फिर और रोटेट करोगे तो कैसे आएगा, ऐसे। फिर रोटेट करोगे तो किधर जाएगा, ऊपर जाएगा। इजंट इट, सी हियर, आई एम जस्ट पुटिंग इट हियर, ठीक। रोटेट इट, देखो ये ऐसे है ना, अब हमको क्या रहता है, आई हैव टू रोटेट इट। सो रोटेट इट, हाउ, इफ आई रोटेट इट, हाउ इट इज कमिंग डाउन, करेक्ट, यहां पे आ गया। आफ्टर रोटेशन वेयर इट विल गो अप। आफ्टर रोटेशन कहां जाएगा, ये ऊपर जाएगा। अब देखो फिर रोटेट करो, कहां आएगा, ऐसे। सो इफ यू रोटेट इट इन द एंटी क्लॉकवाइज डायरेक्शन, ये इस तरीके से रोटेट करेगा, राइट, इजंट इट, फाइन। So after rotation this circle will come here, after rotation this circle will come here, and after rotation this circle will come here, correct, fine. So everywhere the rotation is in the anti-clockwise direction, everywhere the rotation is in the anti-clockwise direction, करेक्ट। देखो आपको सामने फिर से मैं दिखा रहा हूँ, ये ऐसे है ना। आप चाहो तो आप घर के अंदर ये है ना थाली वाली लेकर के भी कर सकते हो, प्लेट्स यू कैन टेक एंड यू कैन सी इट, राइट। तो इफ आई रोटेट इट इन द एंटी क्लॉकवाइज डायरेक्शन, ये किधर आ जा रहा है, देखो नीचे आ जा रहा है, इजंट इट। सो इफ यू रोटेट इट इट विल कम लाइक दिस, देखो। लेकिन अगर इफ आई रोटेट इन द क्लॉकवाइज डायरेक्शन, क्लॉकवाइज मतलब क्या हो गया, देखो है ना, जैसे रोटी सेकते हैं ना तवे पे, ऐसे ऐसे सेकते हैं ना, करेक्ट। तो ये हो गया, ठीक। बताओ क्लियर है चीज। नाउ लेट अस कंसीडर, से दिस इज द सेंटर एंड लेट अस से दिस इज द पॉइंट, है ना। ध्यान से देखते रहिएगा, दिस इज वन पॉइंट, दिस इज अनदर पॉइंट, दिस इज अनदर पॉइंट, and this is your O dash, this is your O, right. So let us say this point is A, this point is B, and let us say this point is C, correct. जब ये पॉइंट नीचे आएगा, when it is going to rotate, so where the point will come, ध्यान से देखते रहिएगा, है ना। ये ऐसे है, correct. You can see that this is the point. So when I am rotating it, so you can see that this is the situation, है ना, ये situation है ना। So when I am rotating it, what it is going to happen, ये ऊपर चला जा रहा है। When I am rotating, ये कहाँ जा रहा है, it is going towards the left, यानी कि after rotation ये कहाँ चला जा रहा है, करेक्ट। दिस इज योर O dash, दिस इज A, दिस इज B एंड दिस इज C, है ना। तो देखो ये कहां पे आ गया, यहां आ गया। फर्दर एंटी क्लॉकवाइज रोटेट करो। सो इफ आई रोटेट इन द एंटी क्लॉकवाइज डायरेक्शन, वेयर इट इज कमिंग टुवर्ड्स द लेफ्ट, मतलब ओ डैश, ए बी सी, फाइनली कहाँ आ जाएगा? सो फाइनली जो आएगा वो किधर आएगा? देखो, राइट, ए बी सी, इट इज समवेयर हियर, राइट. नाउ रोटेट इट, किधर जा रही है? ऊपर की तरफ, isn't it? So it is going upward. C B A O dash O O, चलो O, ठीक है, क्लियर? बताओ, दिस इज द रोटेशन. ये कहाँ से एक्स्ट्रा आ गया? हटा दो इसको. बताओ, एनी डाउट टिल हियर? ठीक है. So that means, it means that from here it is going like this, from here it is coming like this, from here it is going like this, and from here it is going like this, isn't it? So this is how the situation is going, correct? Now let me call this as figure number 1, right? So this is a figure number 1. This is figure number 2, this is figure number 3, and let us say this is figure number 4. अच्छा, ये उल्टा लिख कर दिया ना, सॉरी, ये उल्टा हो गया. हाँ, ये उल्टा हो गया, सॉरी. ये उल्टा लिख कर दिया, सॉरी. दिस इज ओ डैश, ओ डैश, ये अंदर वाला ए है, दिस इज बी एंड दिस इज सी, है ना? देखो, ध्यान से देखो, एक्चुअली उल्टा, हाँ ये नीचे होगा. सी, वेरी केयरफुली, वो गलती से हो गया. यस, करेक्ट, सॉरी. ये देखो, यहाँ पे है, ध्यान से देखो, ये यहाँ पे था, isn't it? So it was here. After rotation, ये कहाँ चला गया? So ऊपर आ गया. So this is the situation. After rotation, where it is going? So after rotation, it is going here. तो ये कहाँ गया? यहाँ आ गया. After rotation, ये कहाँ जाएगा? नीचे आ जाएगा. तो नीचे होगा, गलती से ऊपर लिखा कर दिया था, राइट? ठीक, यही है ना? देखो, आप फिर से देखो, ये ऐसे था, राइट? तो जब ये रोटेट कर रहा है तो ये किधर जा रहा है? ऊपर. सो इट इज गोइंग अप, तो ये अप हो गया. आफ्टर रोटेशन वेयर इट इज गोइंग? इट इज गोइंग टुवर्ड्स द इधर, तो ये ऐसा सिचुएशन आ गया. इसके बाद जब रोटेट करेगा तो ये ऊपर जाएगा ना, तो पॉइंट नीचे आ जाएगा, करेक्ट? ठीक है, नो इट्स फाइन, यस करेक्ट, हाँ गलती से हो गया था, सो थैंक्स फॉर करेक्टिंग, हाँ वो हो गया था, गलत हो जाता है कभी कभी, इतना चीज़ है ना। अब देखो सबसे पहले, नाउ आई एम गोइंग टू प्लॉट द कर्व फॉर ए, then I will plot the curve for B, and finally I will plot the curve for C. We have 3 points A, B, C. So how many curves we are going to get? We are going to get 3 curves, isn't it? Okay. तो चलो पहला कर्व देखते हैं, राइट। सो C के लिए हमें चेक करना है, राइट। सो वी हैव टू चेक फॉर C. सी वेरी केयरफुली, ठीक है। देखो where is C point? You will say that C point is somewhere here, correct? This is C from the figure number 1. From figure number 2, where is C? You will say that C point is somewhere here. Okay, so first let me, ऐसे बनाएंगे ना तो बहुत ये हो जाएगा, फिर मुझे मिटाना पड़ जाएगा, तो just wait. पहले कर्व ही बना लेते हैं, सस्पेंस लग के कोई फायदा है नहीं। Right, see from the graph 1, where is the points? Okay, so हम लोग पहले A के लिए बना रहे हैं ना, not for C, हम लोग पहले A के लिए बना रहे हैं। Okay, क्या हो रहा है, ध्यान से देखते रहिएगा, ठीक है। फॉर फिगर फॉर A, where is the A point initially? This is the from figure number 1. From figure number 2, where is your A? You will say it is here. From figure number 3, where is A? From figure number 4, where is A? So these are the location of the point A, isn't it? So these are the location of point A. So what it is forming? It is forming an ellipse. ये तो हाइपोसाइक्लर बना ही नहीं, ये क्या बन गया, एलिप्स बन गया ना। सो दिस इज योर एलिप्स। सो इफ द पॉइंट इज इनसाइड द जनरेटिंग सर्कल such that the generating circle is half of the radius of the directing circle, so you are going to get an ellipse, correct? If I check for the B point, B के लिए देखो from figure 1, from figure 1 B के लिए कहाँ पे है? So this is from figure 1, this is the position of point B. Next, where is B? B is here. From second figure. From third figure, where is B? From third figure, B is here. And from fourth figure, where is B? So B 2 and 4, it is coinciding, isn't it? It means what? It means that it is going to trace what? Straight line. क्या बन गया ये? So the curve that is traced, it is your straight line. And this question was asked in ESE 2017. Question was, it is given in a workbook. So if the radius of the if the radius of generating circle is half of that of the directing circle, and the point is lying on the generating circle, then what is the curve it is traced, right? So you can see that it is straight line, है ना? अब देखो B point के लिए. Now coming for the C point. ठीक है. So initially C point was here from the figure number 1. Then in figure number 2, where is C? C is upward. This is from figure number 2, position of C. Figure number 3, position of C. And figure number 4, it is position of C. Again what it is forming? It is forming ellipse. देखो आपके सामने हमने बनाया, कुछ भी ऐसा नहीं है कि हमने, राइट। नाउ वेयर दिस स्ट्रेट लाइन्स आर यूज्ड, सो देखो इस सब का उतना ज़्यादा एप्लीकेशन है जितना बी का है, राइट। सो आई होप इट इज क्लियर, पहले इतना देख लो, यहाँ तक क्लियर है एवरीवन? एवरीवन इट इज क्लियर? है ना, देखो अच्छा, स्ट्रेट लाइंस, इसका एप्लीकेशन का है, एप्लीकेशन टेक्सटाइल इंडस्ट्री, पेपर इंडस्ट्री, स्टीम इंजिन्स, देखो कैसे, देखो ये वो कर्व है, राइट। वाई? इट इज बिकॉज सी इट इज कन्वर्टिंग द रोटेटरी मोशन इनटू ट्रांसलेटरी मोशन, है ना। देखो ये दोनों, ये पहिया है, दिस व्हील इज रोटेटिंग बट द curve is tracing is forward. That means in the textile industries or suppose printing machine, in printing machine the driver or the driven, it will rotate, right. So that means it will always, there will be circular motion of the wheel, but the printing should be done horizontally. If suppose you want to print something on the on any cloth, so printing should be horizontal. Similarly, if you want to print a paper, so horizontal printing is there. So machine is rotating in the circular motion, but the printing is done in the horizontal motion. So to convert the rotary motion into linear motion, this kind of curves are used, right. So that therefore it will rotate. So fine, so it will rotate it, you have to fasten your thing at a particular appropriate position, that means at the circumference of the circle, and when the circle will rotate, there will be only horizontal motion. In the steam locomotive also, the piston goes in and out, but the wheel rotates, or you can say that the wheel is rotating and the piston is going horizontal and means in the horizontal direction. So in the steam engine you have seen, right. तो steam engine में क्या होता है, चक्के तो घूमते गोल गोल, लेकिन जो आपका पिस्टन होता है वो हॉरिजॉन्टली मूव करता है. सो दैट मीन्स हॉरिजॉन्टल मोशन इनटू सर्कुलर मोशन. सो दैट इज व्हाई इट इज वेरी वेरी इंपॉर्टेंट, और वही चीज इंजीनियरिंग सर्विस में पूछा गया था. Right, I hope it is clear. So that is why at n equal to 2 or k equal to 2 you cannot get any hypocycloid, but from k equal to 3, if you see this figure, this is k equal to 3, so from k equal to 3 you will get the rotation, right. So this is the figure that I am talking about. So see, there is a circular motion and it is converted into linear motion. So this kind of concept is used in steam engine, textile industry, paper industry and so on, right. तो गोल गोल घूमता रहेगा चक्का, और ट्रेस जो होगा इट विल बी ऑलवेज हॉरिजॉन्टल. समझ में आ गया चीज, है ना, कि बढ़िया चीज, राइट. नाउ सी, दिस इज एन एलिप्स. देखो एलिप्स बन रहा है कि नहीं. द पॉइंट इज लाइंग आउटसाइड द, यू कैन सी दैट द जनरेटिंग सर्कल इज हाफ ऑफ द रेडियस ऑफ द डायरेक्टिंग सर्कल. डायरेक्टिंग सर्कल छोटा है, लेकिन ये जो कर्व बना रहा है वो कैसा बना रहा है, इट इज एलिप्स, जो हमने यहाँ पे बना रखा है ना. देखो ये सी वाला, ये वाला बन रहा है ना, सी ये बन रहा है एलिप्स, है ना. देखो आपके सामने ये चीज. सो इट इज फॉर्मिंग एन एलिप्स. नाउ हियर इट इज फॉर्मिंग अनदर एलिप्स, लेकिन पॉइंट का है, इट इज लाइंग इनसाइड द जनरेटिंग सर्कल. पॉइंट लाइंग इन द इनसाइड द जनरेटिंग सर्कल एंड रेडियस इज हाफ ऑफ द डायरेक्टिंग सर्कल. देखो क्या बन जा रहा है, फिर से यही बन जा रहा है पॉइंट ए जो हमने डिस्कस किया, दैट इज योर एलिप्स. ठीक है, आई होप थिंग्स आर क्लियर. सो दिस इज स्मॉलर एलिप्स, दिस इज योर लार्जर एलिप्स, and this is your ठीक, समझिए। तो अब हम इसको क्या करेंगे, वी विल समराइज इट। नोट की पॉइंट कहाँ नोट लिखवाया, बताओ, क्लियर हो गया, एनी डाउट? ठीक, तो चलो ये तीन चीज समझ में आ गया, ये तीन चीज आ गया। तो अब हम इसको क्या करते हैं, टेबल में कन्वर्ट कर देते हैं। ठीक है, फिर से मैं दिखा देता हूं। दिस इज अ स्ट्रेट लाइन, ये हो गया k इक्वल टू 3, दिस इज अ बिगर इलिप्स एंड दिस इज अ स्मॉलर इलिप्स। ठीक, तो चलो इसका हम एक टेबल बना देते हैं। सो रेडीमेड टेबल, क्योंकि आपको इतना चीज़ कहाँ से याद रखोगे, तो इसको मैं एक ढंग से तैयार करके देता हूँ आपके लिए। क्या ये रेडियस रेशियो के, हाइपोसाइक्लाइड d is equal to r, superior hypotrochoid d greater than r, inferior hypotrochoid d less than r. K equal to 1, R equal to R, K equal to 2, R equal to 2R, K equal to 3, R equal to 3R, right? So in this we have seen that the curve is formed like this, right? Here node formation will be there, here. K equal to 1, it is invalid case, it is also invalid, it is also invalid, sub invalid, right? Now K equal to 2, straight line, ellipse, ellipse. So this is K equal to 3. This is called as deltoid, called as deltoid. नोट कर लीजिए. So after you finished, please tell me. हो गया, सब लोग लिख लिया। इनवैलिड लिखे, हाँ इनवैलिड लिखे ना, क्योंकि k इक्वल टू 1 कहाँ वैलिड है, इनवैलिड है ना, उसमें तो हाइपरसाइक्लाइड बन ही नहीं रहा है, वी आर नॉट गेटिंग हाइपरसाइक्लाइड। ठीक, चलो आगे चलते हैं जरा। नेक्स्ट सेकेंड वन इज योर इनवॉल्यूट। अब इनवॉल्यूट क्या होता है ये भी जरा देख लेते हैं। ठीक, इनवॉल्यूट देखो होता क्या है इनवॉल्यूट, जरा एनिमेशन देखो, इसको ध्यान से देखो क्या हो क्या रहा है। यू कैन सी दैट देयर इज अ थ्रेड विच इज अनवाइंडिंग, है ना, एक सर्कल से अ थ्रेड इज अनवाइंडिंग। The curve that is traced, you can see that the red color curve, this red color curve is basically called as involute. So when a thread unwinds from a circle or any polygon, the curve traced is called as involute. ठीक, इसको बोलते हैं involute, right? तो चलो involute क्या होता है? So it is the curve, it is the curve traced by, it is the curve traced by the end of a thread which unwinds from either polygon or from circle such that the thread is tight, such that the thread is kept tight. थ्रेड को हमेशा आपको टाइट रखना है। जैसे कि एग्जाम्पल, say this is the circle, correct, suppose this is the thread, this is the end point of the thread, correct. So what I have done, so I have tightened a thread over it, एक कोई टाइट कर दिया स्ट्रिंग या थ्रेड, इसके ऊपर टाइट कर दिया। नाउ यू हैव टू ओपन इट, राइट। सो व्हेन यू आर गोइंग टू ओपन इट, so after some time what is going to happen, so after some time this thread will come over here, correct। इसके बाद थ्रेड क्या होगा, थोड़ा सा लंबा होगा, और इसके बाद थ्रेड it will increase its length, finally the thread will be something like this, है ना, ऐसा ही होगा ना। So initially the thread will point is here, so initially the end of the thread, जैसे आप खोलोगे यहाँ आएगा, और जैसे खोलो यहाँ आएगा, और जैसे खोलो यहाँ आएगा। So what you have to do, you have to join these points, right। Isn't it? So this is called as involute, this is called as involute। आई बात समझ में, इसी को बोलते हैं involute। Where it is used, गियर टीथ प्रोफाइल के लिए, इट इज यूज्ड फॉर गियर टीथ प्रोफाइल, गियर टीथ प्रोफाइल के डिजाइन को बनाने के लिए यूज किया जाता है। करेक्ट. सो दिस इज व्हाट आई हैव शोन हियर. देखो फिर से फिगर को, ऐसे है ना, धागा खुल रहा है, तो धागा खोलोगे तो फिर ये स्पाइरल सॉरी इन्वोल्यूट बनता जाएगा, इसको बोलते हैं इन्वोल्यूट. सो व्हेन अ थ्रेड इज अनवाउंड फ्रॉम अ सर्कल, और सर्कल की जगह पॉलीगन भी हो सकता है, मे बी इट इज ए स्क्वायर, मे बी इट इज ए रेक्टेंगल, सॉरी ट्रायंगल, ये पेंटागन, कुछ भी हो सकता है, इसको बोलते हैं इन्वोल्यूट. यूज कहाँ करते हैं? गियर टीथ प्रोफाइल. कैसे? देखो, दिस इज द परफेक्ट मेशिंग ऑफ टू गियर टीथ, राइट, परफेक्ट मेशिंग. अब एक चीज आप ध्यान से देखो, है ना. सो दिस इज द इन्वोल्यूट. राइट, दिस प्रोफाइल, ये सारे प्रोफाइल, इसी को इन्वोल्यूट बोलते हैं. करेक्ट, दिस इज कॉल्ड एज इन्वोल्यूट प्रोफाइल. ये जो प्रोफाइल दिख रहा है ना, इसको बोलते हैं गियर टीथ का इन्वोल्यूट प्रोफाइल. करेक्ट. देखो, ये जो प्रोफाइल दिख रहा है ना, दिस प्रोफाइल्स, ये वाला काला, सो दिस ब्लैक लाइन, ये जो है, दिस आर कॉल्ड एज इन्वोल्यूट. यू कैन सी दैट इन्वोल्यूट प्रोफाइल इज यूज फॉर द गियर टीथ, यानी कि देयर इज अ परफेक्ट मेशिंग. सो देयर इज अ परफेक्ट मेशिंग. आपको दिख रहा है ना कितना परफेक्टली मेश कर जा रहा है ये चीज, तो यहां पे इसका इस्तेमाल करते हैं. करेक्ट. क्या हो गया, इसको अटक गया क्या? है ना, परफेक्ट मेशिंग. ठीक, समझ में आ गया इन्वोल्यूट. करेक्ट. सो दिस इज योर इन्वोल्यूट. अब नेक्स्ट चलते हैं स्पाइरल. नेक्स्ट वी हैव स्पाइरल. क्लियर? Next, third is your spiral. What is spiral? See, it is a curve traced by a point moving with certain velocity v, moving along a particular direction, moving along a particular direction, moving along a particular direction on a straight line, on a straight line with certain velocity v, with certain velocity v, and the line rotates, and the line rotates या फिर and the line has, and the line has an angular velocity. The line has an angular velocity about a fixed point. Angular velocity omega omega about a fixed point called as pole. ठीक, about a fixed point called as pole. So let us take an example. So I will take two examples to illustrate about the spiral. ठीक है, देखो So listen very carefully. Let us say this point is O, correct? O is fixed, which is called as pole. Now what I am saying is, इसको क्या बोलते हैं? पोल बोलते हैं. स्पाइरल क्या बनता है? ध्यान से सुनिएगा, राइट? सो स्पाइरल, सी दिस इज स्ट्रेट लाइन, करेक्ट? पहले समझ लो, देन यू विल अंडरस्टैंड द डेफिनेशन. दिस इज स्ट्रेट लाइन, राइट? सो यू फिक्स द स्ट्रेट लाइन एट वन पॉइंट, कर दिया फिक्स. Now you start to rotate it. There is some angular velocity. So due to this angular velocity, there will be some motion, circular motion, correct? So suppose it is moving with certain angular velocity. So what I am saying that, and simultaneously let us say an ant or any point or any particle, it is moving along this line in a particular direction on a straight line, correct? Suppose some object is moving, or some point is moving, or some ant, some spider, anything is moving like this. So it will have certain velocity, and the line is rotating also. So what is the curve plotted by this point, which has linear velocity, and this is rotating. So the curve that will be traced, it is called as spiral. It is a curve traced by a point moving along a particular direction on a straight line with certain velocity. Suppose some particle is moving along a straight line with certain velocity, and the line is having some angular velocity about a fixed point called as pole. It is called as spiral. Now see one by one. Let us say this OA is a line, correct? Let us consider OA is a straight line, and this straight line has certain angular velocity. Let us say this is at t is equal to 0. So at t is equal to 0, this line is over here, correct? So it has an angular velocity, so it will rotate like this. So that means let us say at t is equal to t1, it is somewhere here, right? So this point is A, having angular velocity omega. So let us say this is at t is equal to t2. Similarly, this is the position of the point A, right? So these are the position of the point A, correct? So here it is A, this is also A. At what time? At t is equal to say t3. Similarly, after some time this A will come here having angular velocity omega. So at what time? So at t is equal to t4. Similarly, here again A will come at t is equal to t5. Again here A will come having angular velocity omega at t is equal to t6, and let us say again A will come here at t is equal to t7, and again it will come at t8, and so on, it will rotate, correct? So if you look at, right, so if you look at the locus of A, it is going to trace a circle. Now a particle is there. Now coming to the next, a particle is there which is over here, correct, having linear velocity v along the line, correct? After some time this particle will go here with velocity v. थोड़ी देर के बाद this particle will climb up with velocity v. After some time this will climb with velocity v, right? This particle has velocity v. Correct? This is what I have written. So the particle is simultaneously moving along a line, and the line is rotating. The curve that is traced, it is called a spiral. करेक्ट? तो ये जो कर्व बना, इसी को क्या बोलते हैं बच्चों? नन्हे मुन्ने बच्चे समझ रहे हो कि नहीं? इसी को बोलते हैं स्पाइरल. क्या बोलते हैं? वी कॉल इट एज स्पाइरल। ठीक है, इसको क्या बोलते हैं? स्पाइरल। बताओ समझ में आया? क्लियर? ये सो आई हैव टेकन वन एग्जांपल, सो लेट अस टेक वन मोर एग्जांपल एंड देन वी विल फिनिश टुडे सेशन। ठीक है, इसमें थोड़ा सा बचा है। टुमारो वी विल स्टार्ट द नेक्स्ट चैप्टर, थियरी ऑफ प्रोजेक्शन। वेरी वेरी इंपॉर्टेंट, बिकॉज प्रोजेक्शन ऑफ पॉइंट्स, लाइंस, सब आगे की पूरी कहानी जो है वो थियरी ऑफ प्रोजेक्शन पे डिपेंडेंट है। बताओ, आई होप थिंग्स आर क्लियर टिल हियर। क्लियर? आगे चले, दूसरा एग्जांपल देख लेते हैं। लेट अस टेक अनदर एग्जांपल, सेकंड एग्जांपल। Clear? Everyone done with it? Now let us come to the example number 2. अभी मत बनाइए, एक सेकंड। सपोज दिस इज अ पेंडुलम, क्या है? पेंडुलम. Suppose it is having some angular velocity omega about fixed point, right? So this is O, which is a pole, correct? Now this pendulum is oscillating like this with certain angular velocity omega. So that means let us say this is at t is equal to 0, at t is equal to t1, t2, then again it is t3, t4, t5, t6, then t7 and again t8, right? So you can see that, so from t0 to t1, so this is how it will oscillate, isn't it? So this is how the oscillation will occur, correct? So it has angular velocity. Now suppose there is a particle, correct? Let us say there is a particle which is exactly at this point at t equal to 0. After some time the particle has come down with velocity v, again it has come down with a velocity v, right? तो अब ये देखो, ये velocity v के साथ ऐसे आ रहा है, right? So initially particle is here, so at t1 when the pendulum has gone here, so particle has climbed down, again it has climbed down, again it will climb down, climb down, climb down, climb down, climb down and finally climb down, correct? यही होगा. So now what you have to do is you have to join it, correct? So if I join it, I am going to get a curve, isn't it? So if I join these points, I am going to get a curve. So this curve is also called as spiral, क्योंकि definition को satisfy कर दिया इसने, है ना? So this curve is also called as spiral. Fine. So this is also called as spiral. Why? Because it is satisfying the definition, angular velocity as well as linear velocity. ठीक है, तो चलिए आज इतना ही करते हैं, बाकी कल हम लोग करते हैं, ठीक है? So I hope you have enjoyed today's session, you have learned a lot. So thank you everyone, see you tomorrow. ठीक है, तो सेम टाइम सेम जगह, चलो ठीक है, बताओ क्लियर है यहाँ तक? किसी को डाउट है, दे कैन आस्क, एल्स वी कैन वांट.